Since carousels use circular motion, we're going to be using our circular motion equations, which are tangential velocity equals 2 pi times the radius over the period. Centripetal acceleration equals tangential velocity squared over the radius, and centripetal force equals mass times centripetal acceleration. When doing the calculations, we're going to get a different answer depending on whether we choose a horse from the inner row of horses or from the outer row of horses. The carousel at Six Flags has two rows of horses. There are horses in an inner row and horses in an outer row. When we calculate tangential velocity for a horse in the outer row, it comes to, with our experimental data, it comes to about 1.8 meters per second. Then if you were to calculate it for a horse in the inner row, it would be the velocity would be smaller because a horse in the inner row has a smaller radius, and we know that tangential velocity, which is used for circular motion, is 2 pi r over t, in which r is the radius and t is the period. This also means that there's a higher acceleration for a horse in the outer row, since centripetal acceleration is velocity squared over r, in which r is the radius. And once again, since a horse in the outer row has a larger radius, it would experience a higher acceleration than a horse in the inner row. And this is why the outer row is considered the more thrilling part of the ride.